So we're doing number 18, which says we have a point on the terminal side of an angle. Find the 6 trig function. So we have the point -5, -12, which is 5 units to the left and 12 units down. This is a third quadrant point. So we can draw our right triangle like this, because we never draw the right angle at the origin. Okay, this is always the angle we're talking about, which has an this x length of -5 and a y length of -12. Hopefully you know something about Pythagorean triples. So if I have a side of 5 and a side of 12, that means I automatically have a radius of 13, because 5 squared plus 12 squared equals 13 squared. So now that I have my 3 lengths, I can write down all my ratios. So sine is y over r, -12/13. Cosine is x over r, -5/13. And tangent is y over x. Negative over a negative is +12/5. Okay, cosecant is the reciprocal of the sine, so r over y, -13/12. Secant is the reciprocal of the cosine, so r over x, -13/5. And cotangent is the reciprocal of the tangent, x over y, which is 5/12. And part B says we now have the point 4, -3. So this is a fourth quadrant point, 4 units to the right and 3 units down. Okay, so there's the point. We can draw our triangle in the fourth quadrant, where this is your angle, with an x value of 4 and a y value of -3. Once again, our Pythagorean triple says 4 and 3 squared together is a 25, so it has a radius of 5. And our trig values are the same ratios. So sine will be -3/5. Cosine will be x over r, so 4/5. And tangent is y, -3/x, +4. And then these ones are the reciprocals, so -5/3, +5/4, and -4/3. So from the point, you're able to draw a triangle in space with the x-axis, where the right angle is never at the origin, because that would not include this point.